Alright, continuing our work now with simultaneous equations. We're going to look at some examples of how we use simultaneous equations in solving problems, as the heading there says. So perhaps that's something you could take down your books. As I say, with these screencasts, do pause, take notes, and do the problems. Try, as I'm doing these examples, perhaps you could try them on yourself. Try and get the solutions before I do. That way, you'll learn so much more. But if you wish, just take the solutions down and come to class with those, and then you can attack the work requirements. So we're looking at exercise 1K, and I'm looking at, actually, these examples are straight out of the textbook. So you'll see them in the textbook, but hopefully with my explanations you'll be able to understand what's going on with these. Okay, so let's have a look at the first example. The sum of the ages of two children is 17, and the difference in their ages is 5. If Cara is the older sister of Ben, determine their ages. Now, we could probably use trial and error here, because the sum is 17, so you could say 10 and 7. Oh, that's difference is 3. So I'll go 11 and 6. Yeah, there it is. There, that was fast. So you can do it that way, and that'll be quicker. But in reality, what we're going to end up with is questions that we're not going to be able to guess by trial and error. Will take us forever. So a much more efficient method is to use algebra. So in order to set this up, what we need to do is we need to attribute some of the variables in here. We need to attribute variables to some of the aspects of this question. So the ages of two children. It's Cara and Ben. So let's give Cara X and Ben Y. Then that will read the sum of the ages of two children is 17. So X plus Y. So what I'm saying here is I'm going to let Cara's age be X, and let Ben's age be Y. So therefore, from that we can come up with two equations. The sum of the ages of two children is 17. So I'm going to rewrite that as X plus Y equals 17. So what my task is to do is to turn the words in the question into an algebraic equation using the variables that I've introduced here and here. So once you've got this underway, you're really into the questions. Once you've attributed some pronumerals to the subjects of the question, then you're in business. So X plus Y equals 17. They're going to give us another piece of information to get the other equation. The difference in their ages is 5. The difference, Cara is the older sister, so we'll go X minus Y equals 5. So there are my two equations. Once I've got my two equations, most often with these questions, solving them is really quite straightforward, because the challenge is getting to this point. So once you're at this stage, you're pretty much home, because we're getting good now at solving simultaneous equations, I hope. In this one, I'm going to use elimination because I've lined it up nicely, and it's going to be the easiest method for me. Now I've got a choice. I could do X minus X to eliminate X, or I could do Y plus minus Y to eliminate Y. What I'm going to do, I like adding more than subtracting, so I am going to add these two equations together. So X plus X gives me 2X, Y plus minus Y, gone. Now the question came up yesterday quite a bit in applying this rule. Think of it in this way. Do we add or subtract? Think of it like this. Decide what you're going to eliminate. If you're going to eliminate X or Y, I always look for opposite signs. Now my Y's have opposite signs, so I'm going to go for that, because that means I can add. If I add opposites, I get 0. If I was working on eliminating X here, they've got the same sign. They're both positive, so I would need to subtract. But I am eliminating Y. Y's are gone, so I'm adding X plus X, 2X, Y plus minus Y, gone, 17 plus 5, 22, so X is 11, and Y will equal, that's 11 plus 6 is 17. So importantly with these questions, so I've now solved it, X is 11, Y is 6, but I've got to go back and answer the question. determine their ages. So therefore, Kara is 11 and Ben is 16 years old. Okay, and we're done. Now, I got that by guess and check, but like I said, the method is going to be important to you. It's not always going to be that easy. So let's go to the second question. John buys 3 daffodils and 5 petunias and pays that much. Julia buys 4 daffodils and 3 petunias, pays that much. Determine the cost of each type of flower. So the subject of this, the topic, the focus is on the flowers, the types of flowers. So what we're going to do is attribute our X and Y to the different types of flowers. So let's say the daffodils are going to be X and the petunias are going to be Y. So we're going to let the number of daffodils, equal X, and let the number of petunias equal Y. Okay, so once I've established that, now I need to write out my equation. Julia buys 4 daffodils. 4 daffodils. Daffodils I'm representing with the pronumeral X. So 4 daffodils is 4X. And 3 petunias. That's 3Y. So 4X. Julia buys 4 daffodils, 4X. 3 petunias, 3Y. So 4 daffodils plus 3 petunias equals $26. 4 daffodils, 3 petunias, $26. John buys 3 daffodils and 5 petunias. I've done this back to front in terms of doing Julia before. John doesn't matter. 5 petunias and paid $25. Okay, let's sit back and look at this now. So these are my 2 equations I need to solve simultaneously to find out the numbers of daffodils and petunias that I'm buying, and then from that how much they cost. So can I eliminate my X or Y? Well, actually, look at my X. My X has got, this X has got a 4 in front of it, this X term's got a 3 in front of it. That's not the same number. This Y's got a 3 in front of it, this Y's got a 5 in front of it. That's not the same number. So I've got to do something with these. I can't just eliminate straight away. I'm going to have to tweak the equations. So what are we going to do? Let's make a decision here. Are we going to eliminate? Let's eliminate X this time. I'm going to eliminate X. So I need to make both X's the same. Okay, so I'm looking now for the lowest common multiple of 4 and 3. So if I times this one by 2, I get 8x. If I times it by 3, I get 12x. Oh, can I multiply 3 by something to get 12? Yes, I can. So what I'm looking for is the lowest common multiple of 3 and 4 in this case. So I want to get 12. So this means I'm going to times this equation by 3, and I'm going to times this equation by 4. Because in doing so, I'll end up with 12x here, and I'll end up with 12x here, and then I'll do a subtraction, and then I'll have eliminated my x. Okay, so that's my tactics. So let's go for it. Times this equation by 3. I think what I'll do is I'll wrap this around here. So I'm going to get 12x plus 9y equals 26 3s are 78. I think. Okay, so that's that one. Now I'm going to multiply this equation by 4. So I get 12x plus 20y is equal to 100. Okay, so now I'm in business. I've got 12x there and 12x there. What am I going to do? The signs are the same. They're both positive, so I need to subtract. 12x minus 12x, gone. 9y minus 20y minus 11y. 78 minus 100 minus 22. So from that, y is equal to 2. And if y is equal to 2, 4x, remember now I put y equals 2 into any of my equations, my starting equations, usually I'm going to go back to my originals because they're the easiest ones to work with. So 4x plus, now this is 3y, so I'm working here, y is 2, so that's 6. 3y is 6. It's 26. So 4x is equal to 20. So x is equal to 5. Alright, they're my solutions. Y is 2 and x is 5. What does y represent? Let's go back and answer the question. Y represents petunias, X represents daffodils. So therefore, what does that mean? That my daffodils cost $5. Therefore, daffodils cost $5 each, and petunias cost $2 each. Let's see if that makes sense. 3 daffodils, 15, 5 petunias, 10, 25, perfect. 4 daffodils, 20, plus 3 petunias, 6, 26. It works out. So there we are, we've solved the problem. Important thing about this is that the steps are attribute X and Y to what the context of the question, the topic of the question, the focus of the question, then write your equations, then solve your equations, then finally, really importantly, go back and answer the question. Don't just leave it in terms of X and Y. Okay, have fun with exercise 1K on page 62.